Hello, sixth graders. Welcome to lesson 13.3, mean absolute deviation. Throughout this whole chapter, we've been looking at different ways to describe sets of data, and here's another way we can. One way to describe a set of data is with the mean. However, two data sets may have the same mean but look very different when graphed. When interpreting data sets, it is important to consider how far away the data values are from the mean. So that's what mean absolute deviation is taking a look at the distances of the data points from the mean. The mean of the distances of data values from one mean of the data set is called the mean absolute deviation. As you learned in the investigation that we skipped, mean absolute deviation is a way of describing how to spread out a data set is. The dot plot shows the ages of gymnasts registered for the school team. The mean of the ages is 10. Find the mean absolute deviation of the data. Label each dot plot with its distances from the mean. Okay, so they have told us that the mean of the gymnasts is 10 years old. So we have given other ages, and we need to find out how far those ages are away from 10, the mean. So 8 is 2 away from 10, so each one of those has a distance of 2 units. 9 is 1 unit away from 10. 10 is 0 units away from 10. 12 is 2 units away from our mean, and 13 is 3 units away from our mean. Once we've determined how far each point is from the mean, we need to find the mean of those distances. So we're taking these distances, not the ages, but the distances, and finding the mean of those. So again, 2 plus 2 plus 2 plus 2. Add up all your values. And then divide by the number of values you added. So we've got 18 as our sum, and there are 12 data points. And 18 divided by 12 is 1.5. So the mean absolute deviation of the data is 1.5 years. So again, we're measuring how spread out those data points are from our mean, because it could look very different if I had another set of data that mean was also 10. Let's take a look at another example. Find the mean absolute deviation for both data sets. Explain which data set is more spread out. The number of laps Shauna swam on 5 different days, blah, blah, blah. All right, so they've given us, again, the mean is 7, and they've given us the data points. So now we need to find out how far those are away from our mean. So the first one is given to us. 5 is 2 away from 7. 6 is 1 away from 7. The other 6 is also 1 away from 7. 8 is 1 away from 7. And 10 is 3 away from 7. And I have 5 data points. So our sum is 8. And again, 5 data points. So a little refresher on how to do that. 8 divided by 5. 1, so that's 5. 3. Add your decimal, and a 0, bring it down. 5 goes into 30 6 times. So you have 1.6. So her absolute, I keep saying that backwards, sorry. Mean absolute deviation is 1.6 laps. Now let's do that for Lara's. Lara swam on 5 different days, and there it is as follows. So let's figure out the distances. 1 is 6 away from 7. 3 is 4 away from 7. 7 is 0 away from 7. 11 is 4 away from 7, and 13 is 6 away from 7. Divide that by our 5 data points, and we get a sum of 20 over 5, which simplifies to 4 laps. So they both have the same mean, but the number of laps varies from Shauna's to Lara's swim laps. So the data set of blank's laps is more spread out because the mean absolute deviation of her lap is blank. So we're looking for one that has a greater mean absolute deviation. So in this case, we have Laura's. So Laura's data is more spread out because hers is greater. All right, here is your one practice problem. You can find this problem on page 721 in your math book. Please find the mean absolute deviation. Enjoy the rest of your day.